We're going to look at designing a study to test for correlation, investigating whether or not there is a cause and effect relationship between two variables. So there are two types of studies that we're going to talk about today, experimental versus observational. Experimental is when the person conducting the study has control over the sample that's being studied, how they're going to split that sample up. They're going to have control over the particular variables that they're changing. They're going to have control over how they're measuring. They're going to have control over what happens during the experiment, all of those things. Because they have all the control and there's such rigor going on, they can then say whether or not it is likely that a relationship is cause and effect. Whereas in an observational study, it usually happens kind of looking from the outside at something. Sometimes it's looking at past data based on something else, but it doesn't have the control to minimize outside variables. We're going to talk a little bit more about that as we go through. These outside variables are called extraneous variables. When we're identifying the variables, again, we have three types of variables in this case. We have the independent variable. That's the variable that you're actually going to manipulate yourself as the person running the experiment. And it is what you hypothesize causes the change in the other variable being the dependent variable. And that's the variable that would then be affected by the change in the independent variable. So for example, if I'm looking at weighing a whole bunch of bowls of mini eggs, my independent variable could be the number of mini eggs in the bowls. My dependent variable would then be the weight of the bowl. Extraneous variables are other variables that could affect this relationship. So for example, in the mini egg thing, the extraneous variables could be the bowl that they're in. Are all those bowls the same? Are some bowls heavier than other bowls? That's going to affect my weight a lot. What material are they made out of? What size are the bowls made out of? Another extraneous variable might just be the size of the individual mini eggs themselves, because I'm only counting number of mini eggs. If one bowl had 3 tiny mini eggs and another bowl had, 2 really big mini eggs, they might end up weighing the same amount, even though there's a different number of mini eggs in there. Once you've decided on those things, then you want to try and minimize those extraneous variables. So to do that, you can either set all of them to be equal, like I can put all the mini eggs in the exact same bowl, and if that's possible, that's the best way to do it. But oftentimes, that's not very easy to do. So instead, what we do is we set up 2 groups, a control group and an experimental group. The control group is basically your baseline group. Your experimental group is the group for which you're actually making the changes occur. And so that could just be you're adding 5 mini eggs. That could be something like I am giving this sample of humans a certain drug. That could be something like I am going to test a completely new assembly line for producing my particular manufactured good. So all of this sample is going to go through the new assembly line versus my control group would all go through my old assembly lines. You can have more than one experimental group as well. So if I wanted to look at how well a certain nutritional aspect can affect my diet, let's say I'm looking at number of carbs, I could have an experimental group where I cut out carbs completely. I could have an experimental group where I just reduce carbs by half. I could have an experimental group where I reduce carbs by 75%. Like you can set up different experimental groups. Again, in an experimental study, you want to try and control for those extraneous variables. You can do that by having really large sample size and then randomizing which group a particular participant or object gets assigned. So you're spreading out all the possible extraneous variables between both the control and experimental groups. And so then your characteristics of those groups should be as similar as possible. And what I mean by that is not all the same in one group versus all the same but a different the same in the other group. So I'm going to show you a visual to kind of look at that. So if we look at this where we have our sample at the top here, we have 2 variables that I can see. I can see that some of them are squares and some of them are circles. So one of the variables is shape. Another variable is color. I've got 4 different colors going on. Let's say I want to look at the resale value. That's my dependent variable. And my independent variable that I'm going to actually test is who the seller is. If I give all of these shapes to, I don't know, let's say Lady Gaga, and she tries to sell them on her Instagram versus me trying to sell them on my Instagram, what's the resale value? Okay, so if we're setting up a control group and an experimental group, my could be the control group. So I would be the baseline, just regular Joe Schmo trying to sell these shapes. The experimental group would be all the ones that Lady Gaga gets and she tries to sell. So if we split up the group like this, whereas I sell all or most of the squares and she sells all or most of the circles, what we could actually find out is that all of mine sold for way more money. But that might not be because I'm a better salesperson. It might just be because the squares are worth more. The circles aren't worth very much, so Lady Gaga didn't get much money. Okay, or we could split it up like this. We've split up approximately all the squares and circles, but the colors didn't get split up very well. Lady Gaga's got most of the like reds and oranges, and I've got most of the greens. And then the blues are kind of distributed equally. So if color had a strong effect on the resale value, then that's going to affect who's going to make more money. So what we really want is we want something that looks like this bottom one, where we have all the shapes equally distributed as well as their colors. So then the shape or the color won't affect what's being sold or what amount of monies we're getting by that resale. So that's the idea, by as similar as possible. So for an actual example, not random shapes, there was a study done in 1988 called the Physician's Health Study, and this was looking at if aspirin reduces heart attack rates. So the variables would be presence or dose of aspirin as being independent variable. That's the piece they're going to change. Dependent variable would be the amount of heart attacks, so either the presence of them, the severity of them, or the frequency of them. The extraneous variables could be the age, diet, physical health, gender of the particular person being studied. Again, the whole idea is that we want to try and minimize the effects of those extraneous variables. I don't want to do a study where I figure out, oh yeah, old people have more heart attacks than younger people. Right? That's not the point of the study. The point in the study is to find out if aspirin reduces those heart attack rates. So when you're going to describe a study, this is the first step you would do. You would break it down just like this. You'd say what the purpose is. You'd say what your variables are, independent, dependent, and extraneous variables. Then you'd go on to say, okay, well, how am I actually going to create this study? What am I going to do to make this happen? So one other kind of, I guess, key actual intro pieces would be population versus sample. So my population could just be all adult humans. I want to see if this aspirin works great for any adult humans. So in this particular study, they took a sample of about 22,000 male physicians aged 40 to 84. So it's a very large sample. And it only covers males. We'll talk about that in a little bit. So the experimental group is aspirin being taken every day. Sorry, it says every other day, typo. Control group would be a placebo pill is being taken every day. So what a placebo is it's just a pill without any actual medical ingredients whatsoever. It doesn't do anything. So in order to reduce the effects of these extraneous variables that we listed before, we've eliminated gender as one of them, because we're only looking at males. So that's, again, we were able to completely remove one of those things. And we're minimizing the rest of them because we're randomly distributing a large sample. So again, ideally, those age distributions will be randomly assigned between the control and the experimental. The young people, half of them will go into the control group, half of them will go into the experimental group. The people who are extremely physically fit and have a good diet, half of those will go into control, half of those will go into experimental. The other piece is that it's what's called a double-blind study, meaning that the physicians don't know which study they're in. So they don't know that they're actually getting the drug or not. So then what did they actually do to conduct the study? Well, they completed it over 5 years. Each person took the pill once a day. They didn't know if they were actually getting a drug or not getting a drug. So they also took it at the same time of day with a meal. So that eliminated some other extraneous variables that we didn't actually talk about. But whether or not you take a drug with food or not affects how it actually works in your body. So they've eliminated that variable, extraneous variable. And then the piece they actually measured was the number of heart attacks that occurred in each group. And they decided to measure it as a rate per 1,000 participants. And in order to see if it worked, they're going to look and see which group had a higher heart attack rate per 1,000 participants. And there are scientific studies to say, okay, well, the ratio has to be this high, or the difference has to be this high, and pieces like that, that if you do more statistics in post-secondary, you will learn about those particular studies. We don't actually do them in this course. But this particular study, you can see that it's almost double the amount of heart attacks in the control group as the experimental group. Because of that, I can say that aspirin definitely had an effect, and it definitely worked to reduce the amount of heart attacks that occurred. Sometimes you'll see studies that are a little bit closer together, and then you're like, is that statistically relevant or not? And so you should kind of be starting to think about that and question those things if you see them really close together. Again, in post-secondary, when you do more statistics, you'll learn about, okay, well, how far apart do they actually need to be before I can statistically say that this is cause and effect, that this is significant. In an observational study, going back to the two types of studies, experimental and observational, the best we can actually do in an observational study is to have a large enough number of data points that we could separate the data points based on stratas of your extraneous variables. So if we look at a sports example, on most of the professional sports organization websites, we can't watch sports right now, so we can just go and stare at old stats. You'll see that they actually provide a lot of information. So for hockey, for example, they have columns for number of goals scores, column for what team they're on, column for how long they've been playing, a column for how long they spend on the ice, column for how many penalty minutes, all of that kind of thing. So if we wanted to study a relationship between time on ice and number of points scored, well, there's a bunch of extraneous variables that can come into play there, right? Not just the fact they were on the ice longer. Being on the ice longer maybe wasn't the cause of why they scored more points or didn't score more points or whatever. One of the particular extraneous variables could be their position. So you can actually sort by that, and then you can do kind of different mini studies for each position or just look at one particular position. Obviously, forwards are going to score more goals than defense just based on the nature of their roles on the team. Okay, so that's the kind of general idea behind it. Again, when you're describing your study, you want to be very detailed in your descriptions and really kind of obvious too. So for example, I might be looking at something that is a measurable quantity. And in the last study, we looked at a rate, and we said that if this rate is higher, then I know this drug is higher in the control group, be specific there too, then I know this drug is working to reduce the number. We could also look at like the mean of a particular measurement, and I could say, I know if this mean is higher in my control group, then my particular independent variable is affecting it. But you want to say, what are you going to measure, and what result do you actually want to occur? You can't just say, I'm going to measure this, and it'll tell me whether or not my independent variable actually causes my change in my dependent. Well, how do you know if it changes it? Does it have to be higher? Are you going to look at the mean? Are you going to look at median? Are you going to look at raw data? Are you going to look at a rate? What are you going to find out? Are you going to look at a spread? Because sometimes a spread is really important for these particular types of things. Okay, so what I want you to work on for practice work, first and foremost, I want you to reflect on how this pertains to your actually statistics project that you're working on right now. And then I want you to do some textbook stuff. There's an additional problem assigned through the Google Classroom that basically just gets you to describe a statistical study based on a purpose that I've given you. And I want you to see, or I want to see if you can put enough detail in there that I want to make it really clear exactly what we're going to do. There's some further reading there, so there's 2 different studies as well as just a breakdown of double-blind studies and kind of more scientific rigor in terms of their explanations for what that means and how that goes through. They talk about control group versus experimental group, all of that stuff. Everything we talked about in this presentation, but just in more detail. The 2 studies, you've probably heard on the news that they're currently trying to basically find any treatment they can against COVID-19 and how to kind of minimize the effects of the virus. And so one of them proposed by some politicians and different people is hydrochloroquine. And so that article just talks about what are the couple studies that's based off of, how were they conducted, what were their experimental groups and control groups, and what did they actually find. The second one is about vaccines causing autism, and it talks about a famous study that was done a couple decades ago where a scientist had said that he found a relationship between vaccines and autism. He said he did a controlled experiment with experimental group and a control group. So if you read that article, you kind of see some more information about that and why it's important to properly pick your samples. But the other piece of that I wanted to kind of talk about is just the importance of getting things right the first time and the importance of the idea behind a peer-reviewed article. So what happens as a scientist is you do your study and hopefully you set up all your stuff really well and you select your sample and you evenly distribute between your experimental group and your control group and you're accurately measuring and all that kind of stuff. And then you come out with your findings and you write your detailed report and then you submit it to a scientific journal to get published. Before the journal will actually publish it, they will take your article and they'll send it out to a bunch of other scientists that are in a field similar to yours so they can understand it. And sometimes that field is actually really, really limited. And sometimes people are reading papers that they don't know as much as the original researcher, right? Because there are some things around the world that are being studied at one lab in one particular location. So they have to do as much more research as they can to try and figure out, okay, does this study make sense? Have they done a good job? And then if they'll basically tell you what they want to review and what they want you to fix, they'll send it back to you and it'll go back and forth a couple times. And then if it's okayed, then it'll go to a peer-reviewed journal to be actually published. So that's why it's important to read things based on peer-reviewed journals as opposed to just random stuff written on the internet, and look for your sources, look for where those studies are coming out of, all of that kind of thing. A lot of people always comment how when I'm talking to someone who has an opinion about or is saying something like they believe to be fact or they're trying to convey as fact, and I don't necessarily agree with them, people say that I do a very good job of kind of keeping that conversation going without getting the other person angry. And the biggest thing I do is I just say, oh, that's very interesting. Do you have a scientific study that I could read for that? Do you have any references that you could show me for that? And then I won't actually confront them about if I believe their thing is correct or incorrect until I read that particular study. And if they don't have a study, then I'll talk to them about why that's really important to have some evidence before you start spreading things. But so kind of keep that in mind when you're talking to other people about different things and when you're kind of coming to your own conclusion about the world around you as well. Okay, that's it. Thank you.